All right. Hey, adventurers, and welcome to video 2 of floor 10. In our first video on this floor, we wrote the index, where we populate all three containers, and knows, which is membership, in one call. Our self-test registry phases 1 and 2 are green. The weakness command shows the distinct set is already sorted, but nothing has been populated in it yet. It shows zeros for everything there. Our phases 3 through 5 still fail. So we have a couple methods here today, one per container. We're going to have recall, which is going to be using the standard maps find method, which returns the whole record or a null pointer if not found. We're going to work on has weakness, which uses standard sets count, which is a membership test against the set. And then we're also going to have count weakness, which uses standard maps find method again on the counts map. We're not going to use the operator bracket, because remember, if you use operator bracket, remember what that has? It has write access, not just read. So remember that. So a couple things to carry today's video. First, recall is really the punchline of this whole stretch. Floor 9's recall was a recursive tree descent that we wrote. Today, it's using one find. Once again, we're kind of jumping over to really focusing on what's in the standard library. Second, our count weakness is where the phantom key lives. The operator bracket on a missing key inserts. That's what I was just talking about a second ago. Now, our count weakness method here is const, so our bracket won't even compile there. And so essentially the idea here is you design a way and make the bug impossible. Now, the registry's lookup method is named recall, which is really a story echo back to floor 9. But floor 9's recall REPL command still drives the BST and is unchanged. So the registry's lookup runs at the prompt as lookup, not recall. When we edit the method, we type recall, and when we run the demo, we're going to use lookup. Okay. So just want to make sure you understand that the old recall is still here and still present. We're just not going to be focusing on that here today. Okay. All right. So let's go ahead, and we finished here with knows last time. Okay. So we should be right here ready for let's see. Before we edit these, I wanted to show you our find from function first here. Let's find that real quick. Let's go to hero/bst header file, and let's go on down to the find from. Let's see, height from, find from. Okay, so I want you to focus right here real quick with me. Now, before we write today's recall, let's look at what recall used to be. On floor 9, we wrote this right here. It's a recursive descent. We have a null check, a compare, go left, go right, recurse, return the node. A whole function, and behind it, a whole class that you built and tested across a whole floor. It works. It's O of log n on a balanced tree. Now watch what it becomes when the balanced tree is the libraries. Let's go back to our registry header file now, and let's go to our recall right here. And so this should be starting here, line 128, where we start with Wednesday's material here. Okay, so let's fill this out. So we need to say auto it equals by name, find name. They'll say return it equivalent to by name end question mark null pointer. Otherwise, it second. Okay, so really just 2 lines here. By name, find of name gives us an iterator. If that iterator equals end, the name isn't here. Therefore, we return a null pointer, which is exactly like floor 9's fall off the bottom. Otherwise, we return the address of it second, which the arrow gives us the pair that the iterator points at. Now, the second is the monster value, okay? And we hand back a pointer to it. That's the entire recursive descent from last floor collapsed into one find against a tree the library balances for us. So 2 notes here. The method is named recall, same word McCown used on floor 9 on purpose, but at the prompt we'll run it as lookup because floor 9's recall command still drives the BST that we did before. And another thing here, you'll notice that this is const as well. Okay, so find never inserts. Okay, and so asking questions of it is safe. What did we give up by switching? Nothing you needed, really. What did you gain? Correctness, guaranteed balanced, and a function that's 2 lines instead of a class. Hot dog. Okay, let's now go down here to our has weakness. And let's go ahead and fill this one out. So for has weakness, we really just need to return the weaknesses dot count of W greater than 0. Boom. Okay, so this looks just like Monday's nose, count greater than 0, and that's the lesson. No asks the map, is this name a key? This asks the set, is this weakness present? A standard set count method returns 0 or 1, same as a map, because a set holds distinct elements. It's the same shape, it's just a different container and a different question. Knows is membership against keys that have values. Has weakness is membership against bare values with no payload. That's exactly when you reach for a set instead of a map, when you only need to know it's there, not get anything back. 1 line as well. 1 line, it's you also notice it's const as well, and there's also no loop over a bestiary object. Okay, and then let's go do our count weakness stub here as well. Okay, so we'll say auto it for iterator. We'll say weakness counts dot find W, and then we'll say return it equivalent to weakness counts dot end question mark 0 it second. Okay, so here's the one that has a trap right here. We want the count for a weakness or 0 if none. The obvious thing and the wrong thing is to write return weakness counts bracket of W. Don't do that. On a standard map, the square bracket on a missing key doesn't return 0 and walk away. It default constructs a 0 and inserts it. So asking how many of these monsters fear thunder with the bracket would actually create you a thunder entry count of 0, a weakness actually that nothing has. And now your distinct weakness shelf is polluted by a question you only meant to ask, not add to it. That's what we call the phantom key, a read that actually writes. The fix is find. It returns an iterator, never inserts. If it's end, return 0, else return the second attribute of it. And here's the safety net here. This method is also const. Hot dog. On a const map, our operator bracket won't even compile because bracket might mutate. So even if your fingers reach for the bracket out of habit, the compiler will stop you. The right design makes the bug impossible. So let's go ahead and build our executable here. Okay. All right, and so we will say self-test registry. And so now we've moved up here So you know our recall, has weakness, count weakness, all good there. So phases 3, 4, and 5 are green. Recall returns Wraith's record and a null pointer for Drake. Has weakness, finds holy, rejects water. And then our count weakness reads holy as 3 and a missing weakness as a 0 without inserting it. So only phase 6 forget is left for the next video. And now we can do our catalog checking out. So I can say lookup lich. Perfect. It's there. Weakness fire. 6 monsters fear fire. Perfect. So we can see our lookup with our lich. There it is, the whole record from one find. Remember, the command is lookup, but it calls the registry's recall method. Floor 9's recalls command, remember, is still with the BST. And our weakness fire puts both new methods together. Has weakness asks the set is fire present, and then count weakness asks the map, well, how many? And then we get back 6. So membership and count together there, 2 containers, 1 line of input. And now our moment, our whole map ADT was building towards, we could say names. And of course, here we have our monsters in alphabetical order. We have our weaknesses, all of that looking good. So we have 15 names, all alphabetical, and I never sorted them. Right? Look at how the command here provided names, how the names command iterates. And if we go here, let me minimize this, and let's go on over here. Hold up, let me exit out here, and let's move on back to the we go to our names command here. Let's see, okay, perfect. So let's see here. Okay, here we go. I was blind there a minute ago. In main.cpp, if we look here under the names command, we can see here how it iterates. So we have this for const auto ampersand bracket name comma n registry by name. That bracket name comma m is C++17 structured bindings. When you iterate a standard map, each step hands you a standard pair, specifically a pair of const key and value. And name comma m unpacks the pairs dot first into name and dot second into m, so you don't have to write it arrow first and it arrow second everywhere. The key is const, by the way, and that's not optional. The map's whole order depends on the key, so it won't let you change a key out from under the tree. The pair and its const key are a pair. The fact that it all comes out sorted is a map. And then some of these concepts even, are touched upon in the Xi book as well. Now, structured bindings, you can go read more about that, but that's just a standard C++17 language feature. Okay, and so this should have us pretty much ready to rock. I think there was one other command from last time. I think it was weaknesses. There we go. So we get 6 distinct weaknesses, and you see the counts there of them. And we have them sorted here in alphabetical order as well. Okay, I hope this was helpful, and I will see you in the next one, adventurers. Bye-bye.